Hey, welcome to the vid. I'm Ben. I'm working on a mobile game and I'm using React Native to build it because I thought that was a good idea for some reason. It's a simple enough game, there's not too much complicated stuff going on in the way of graphics, so I can kind of get away with it. As you can see here, it's a space game, it's an MMO, it's a mobile game, and it's kind of about colony building, battling other players, cute critters like these little cats running around. And today what I was going to work on was actually making a new component for the sprites so I can do those little animations a bit easier. So far I've been using this React Native Spritesheet by Me Long. So this is a really neat little package. It's using the React Native driver for all the animations, so it's really smooth. But given that I'm going to be doing a lot of stuff in my game, and I kind of like having more control over stuff, I was going to make my own version of it. So today I'm going to run through making a custom component to do Spritesheet stuff and get a bit more control over the sizing and stuff. So let's have a go at that. So I've got this test view that I've made. It is just this simple screen here. The UI stuff is just from the actual game. I'll leave that up. But see here, it's just a background image. So I've got the React Native image component here. It's absolute position. We're just going to create this sprite sheet, chuck it in here. We'll do that in a separate file. So let's go sprite sheet tsx. I'm using Typescript because I come from a sort of more strongly typed background, like C++ and C, so it's a bit more comfortable for me just having all that typing. So I'm going to go type in yeah, let's go, and get this template for a React class component. So that's a really nice thing I set up, which is a user snippet. If you don't know about user snippets, go to Preferences, User Snippets, click the file for the type of code you're working with, and then you can define your own templates for certain things. So I've just got this set up. You just type in the prefix and smashes it out for you, which is amazing. Saves heaps of time when you've got all these components and stuff you're working with. So we've got this basic template. It's got a TypeScript interface for properties, which will be what we put into the component when we start it up. State, which we'll get to, constructor, and then the render method for actually telling us what the component's going to look like. Right, so I am going to base this off the React Native Spritesheet code to some extent. I will write it all up myself, but yes, I'll be changing quite a few things. So I have an idea of what sort of inputs I might want to have to the component. So if we've got a sprite sheet, pull up this one here. This is the cats from earlier. It's just a low-res version of the cats. So we've just got a bunch of frames spread across an image. We're going to load that in. So what we want to tell it is the number of rows we have, number of columns we have in our image grid. We want to define stuff like the frame rate at which we're going to play our animations. You could have individual frame rates for each animation. That's easy enough to add in later, but I think just a global rate for now is fine. So chuck in, we've got the style there, which I've got as part of my template because it's pretty common to want to pass in a style just for the sort of container item. You can see down here the actual container for this component already includes that style. And then we're going to have the animations themselves. Those will make another interface just to say what is our definition of an animation going to include. So we go animation. We're going to have the row in the image that the animation animation is located at. So if you have multiple rows in that sprite sheet, then each one could contain an animation. That's how I would do it anyway, and this is for my project, so that's how we're going to do it. We want the number of frames this one has. It's not always going to be the number of columns, like some of them will be smaller. So we'll specify the number of frames. I could put an override for the frame rate here, but we'll just stick to global frame rate for now. So that's probably all we need for that at the moment. Oh, I'll give it a name, just a string, so we can identify it. And this will be an array of animations. Okay. So that's passed in. Get to the state a little later. I also need the source image itself. I'll just put this as an any for now, but I can try to type in later. So a good place to start would just be to display the image itself, just without clipping it down to a single frame, just bung the whole thing on there, see what it looks like. So we'll go this dot props dot source, and we'll make a little style for it, just styles of image, just so if there's any styles that won't change during the whole thing, then we can put them in. Okay. So that on its own should just display the image. So rename this to a sprite sheet. Now we'll try putting it in this test view. So we'll just chuck this sprite sheet in here and see how it goes. Sprite sheet from what? Yep. Okay, chuck in the source. Use require assets folder. Critters, cats. Critters run to PNG. It's a very small one. So try that. Just make all these other ones not required for the time being. And we'll try rendering that. And as you can see, we've got a whole bunch of cats there. They're not doing much right now, but they are cats. That's what we wanted. So at this point, what we're going to want to do is contain that entire sprite sheet image within a smaller view, which is going to have any of the image that goes outside that view is going to be clipped off. It's just going to be like with an overflow hidden sort of style. So we're only going to see part of it, and then we're going to use React Native animations to move that sprite sheet across one frame at a time. If we use the React Native animations, it should be pretty smooth with the native driver. So let's take a look at how they did it in our own sprite sheet. See, they've got a single animated value, which is handling all their animations. When you run a play function, which is in the class, it just does an animated timing, which will just basically send that animated value to a desired value over a certain amount of time, and that will just generate a continuous sequence of floating point numbers up to that destination value over time. So if we just directly use something like that and, you know, bunged it on our cats there and had it sort of shrunk down into one frame, what we'd see is just like the image sliding along like a window. What we really want is like discrete movement. So the way they did it was, have a look here. This is from the React Native documentation. I just modified this fading example to show you what I mean. So how they did it was with an interpolation. So you can interpolate an animated value to change basically what output range you get from it. So if you say you want to go from time 0 to 8, then you can take that range 0 to 8 and map it onto a different range. So in our case, we'll be mapping it to a range of different translation values for sliding those cats along. But to make it discrete, what you need to do is this little trick, which is basically you define each potential input range value twice. So this is saying that the range 0 will map to 0.2, but then at this instantaneous jump from 0 to 1, you actually go up to 0.4. And same thing with the next one, so I can show what that looks like. Basically, you're just going to see the opacity is changing in these discrete jumps rather than smoothly transitioning. And that's going to be the same thing we want to do with the translation. So that's something we can code in easy enough. Okay, so we want to do that. Alright, so here we are. We've got our bunch of cats. So let's start off by shrinking that down and cutting off the overflow from it. So we just want to see a single frame at a time. What we can do is, just for now, I'm going to crop it to a square. I probably want to allow for sprite sheets that aren't all square contents for each frame, but for the time being, I'm just going to make them squares. We can do some stuff later and actually track what the size is with some like on layout callbacks and stuff. But for the time being, we'll just keep it square. So we'll make our container a square. Aspect ratio 1 makes a square. Let's see what that does. Okay, so it's still overflowing. So if we do overflow hidden, that should be a string. And it should just be a single cat. Yes, there we go. Alright, now remember this is working because all of the images in the Spritesheet row are squares. So. Okay, because these cats are really tiny, I'm just going to use the next image up and just, let's get some big cats on there for you. Alright, we got a big cat. So, let's start thinking about animations. Make this an animated image, and then this will accept animated values in its style. Just format this a little nicer. I'm going to change this to an array of styles so that we can include this more dynamic one, where we're going to put in a transform. So this is where we are going to chuck in a list of transforms. One for, we'll probably just start off by doing the row transform. So we'll do the horizontal movement of the cat image across. So we'll go translate X, and then some value, a little to do. So we're going to increment that value over time. So let's head into the constructor. I've got a user snippet for animation stuff, so I'm just going to slam that in there and see what we get. Alright, so I've put in an animated value, an animated timing, and a view. Now we don't need the view part because we've got that down below already. So let's start with these. Okay. It's not a function component, we don't need hooks. I've been doing function components for like every other part of this project, so we can just straight up define that, and we will do the same thing. We'll call it time, so we're just going to interpolate time. So we got that, and we've got the timing function. That we will do later. I'll just define this play function. So instead of defining it locally, we're going to go this.state dot time. We'll define time. Time is just animated value. So This is how we do it. We define the whole state at once. Then we go this.state.time. Okay. So we've passed in the sort of definition we want for the animations as a prop, but we're going to want an internal representation of the animations, which is kind of like we've translated it to the information we actually need, which is like the X offsets for each frame, number of frames and such. So we'll start processing that in here, probably before we define that state there. We can always refactor this out as a function later for me, but let's for now iterate through all those animations. And let's go for anim of this.props.anims. And that should be an animation. Yep, that's right. So just before I get ahead of myself here, I'm going to put in just an example animation so nothing crashes on me. Anims equals. Okay, so we've got a definition of an animation in there. It's an example one. We've made that required now, so that's fine. Okay, so let's iterate through each one. There we go. We want to define what? What do we want to define? So for this translate X value, we're going to interpolate time. Like we said, we're going to slide it along in discrete values as time increases. So we're going to go time.interpolate. So we're going to go this.state.time to get it. Input range and output range. Define our mapping. Okay, so we want to pull these from somewhere. So we're going to process them ahead of time and see what these X offsets should be that we're sliding the frames along at. And the same for the inputs. So what we're going to have is a new array of animations, or maybe even we'll make an object and index it by the name. And for each one, we'll have input range and output range. Let me just jot this down. I will make a new little interface. Make an internal animation. Have input, which is just an array of numbers, and output, also an array of numbers, and then we'll make a type, internal anims, which equals key of key string internal anim. So what that's saying is we're just making this object type internal anims, which has strings as indices. So we index the object by string, which will be the name of the animation, and then each value in that object will be one of these internal anims, the input and output ranges for the interpolation. So let us take that and do something with it, and go const internal anims of type internal anims equals. It's a blank object for now. Okay. Then as we go through each animation that we've put in to the component, let's go const anim. Just for now we'll go ianim internals, rather verbose not really keen on that. Let's go equals. Yeah, okay. I'm getting to that VS Code, hang on. So for the input, output, we'll put things in here. But for now, just got that. And then what we want to do is go internal. Okay, let's go I. Names. Dot. Or INM's nm dot name. So that didn't exist in INMs previously. We're just indexing it to create this equals INM. And that's valid because we've set internal anim to be the type of this, and it's expecting a string as key, and internal anim as an object. If we were to put something else there, like blah 3, it won't be happy. So you can see it's not assignable to type internal anim. So good there. So we've got that going on. And now we need to work out what these values will actually be. So the input is going to be a range of numbers from 0 to a number of frames minus 1, I presume. So if we look to what we were doing here, you can see for each frame, we basically just use the number twice, just so we get those discrete steps. The last one is once. We could probably just do a duplicate of that, it won't really matter. So we'll just do 2 of each one. So we'll start off with, alright, so to get these pairs of numbers, I'm just going to make a little helper function for that. So we'll just go const get numpairs equals length number. So go for I equals 0, I is less than length, I equals 1. What am I doing? Const array equals is an array of numbers. Go array dot push I. And we'll do it twice. Wow, smart code. Return array. Use that. Let's do that. We will chuck in get numpairs of name dot frames. I reckon we'll make this frames optional. So if we don't want to specify the number of frames for a particular animation, let's just grab it from the number of columns we've put in. So if the animation goes to the very end of the sprite sheet, then you can just take that columns value and that will be correct. So we'll go double question mark, what are we doing? Default props, no, not default props, this dot state dot, nope, third try, props dot cols. Alright, so that should get us the pairs of inputs. As for outputs, basically we want to start with the first offset value, so that'll just be 0. So it'll start with the 0 and then it will be pairs. Okay, so let's take an array that just has 0 in it, because that's always going to be our first one. And then we will concatenate an array onto that. So So we'll get an array of pairs after that. So first value for first number, second value for second number, third value for third number, fourth value for fourth. So yeah, we'll just get all those pairs of ones after 0. So what that's going to be is, we can use get num pairs again. Get num pairs. And in dot frames minus 1. Because we're ignoring 0. Let me just redefine the number of frames up here, just so we don't have to repeat that check for the default prop. We send frames in there. Here we will go minus 1, because like we said, we already know the first one is 0. And we can do some stuff to this. So what we want to do is, we want to map that to a number. We want to take that and change it into a translation value for the X translation of the cat. So for the time being, I am going to cringe hardcode the width of each frame. Later on, we're going to just grab that from an onLayout callback, work that out dynamically, because that's half the reason I wanted to make this thing, is so that it can do dynamic sizing. But just so we can get this going along, let's go frame width equals 256, because that's what it is. We're going to map these numbers to, and we'll add 1 to it because we're ignoring that 0, and we're going to times that by the frame width. So we start off with 0, and then all the pairs onwards from that will be from the second cat frame onwards. So that'll be 1 times frame width will get you 256. So it's going to be 0, 256, 256, 512, 512 onwards, up until the last offset. And that will work except for the last one, because the lengths will be wrong, because remember we only had 1 on the end here, but we're returning 2 from that get num pairs thing. So we either want to get rid of 1 off the end of the input, or we want to add an extra 1 onto the end of that one. The output. So maybe we just slice it and get that end 1 off. Slice. Returns a section of the array. So we got the beginning of the array will be 0, the end exclusive. So if we go slice from 0 to n frames minus 1, nope, that's not right. 2 times n frames minus 1 should do it. I'm just going to assume that each row is its own animation, and that's just how I'll make my game. So let's deal with that. In these internal animations, we also want to define the Y translation. So that's going to be dependent on which row the animation is from. So in here we will go translate Y equal to anim.row, which we will 0 index when we put it in. So we'll go anim.row times, and make that frame size because they're all squares. Again, these are assumptions, we'll change it later. Frame size. So if it's 0 indexed, then if it's in the first row, or the 0th row, the Y translation will be 0, so we will get the first row. Anything onwards will be 1 times the frame size, so it'll offset by 256, get to the second row, etc., etc. Okay, and we can chuck that Y translation in there. So let's do that. translate y equals, we'll make it 0 for now, but this is where we will use an internal anim dot translate y. So we'll get to that. We'll have something that stores what the current animation is and we'll be able to access that and put it in here as the translation. Anyway, so we've got our inputs, we've got our outputs, we've got our translations. I think we finished up there. So we sliced it, we got this to the right length. We've concatenated 0 with all these other offsets. What can we do next? Well, for a start, we can make this thing autoplay. We do add a param for autoplay. We'll do that later. But for now, we'll just make sure it plays itself. So it's going to go to some value, which will be the length of the animation. At this point, we're going to want to store what the current animation is. Okay, so that will be a name, because if we remember, our internal representation of the animations are indexed by a string, which is going to be the name of the animation. So we want to store the current animation as a string. So to the state, we can add internal animations, which will be this thing we created here, this object. I'll put that in the definition of state, which will be an internal anims object. And after that, have current animation, which will be a string. Okay. Current animation will be what? Let's add a property called default animation. So this default animation you specify when you make the component, and it will correspond to one of the animations in this list. So check that in to our sample one, equals run. Okay. I just saved it and it has broken. What have I done? Unexpected token. Didn't finish my line. So the current animation equals this dot props dot default anim, which is required. We'll just make it required. I'm nitpicking. It's not a biggie. Alright, so we got that stored. Alright, press save. Nothing's happening at this point because we haven't put in our input ranges and actually used this current animation yet. So input range will be this dot state dot internal animations, index it by this dot state dot current animation dot input. That's a little verbose, but we're not going to use these much, hopefully. Dot output. Then same thing here. We'll get that Y translation. I'll save it, see what happens. The cat is gone. That's fun. Done something wrong, clearly. Let's figure out what that is. Just going to do a really dirty console.log and see what our iAnims looks like. Console. Save it. What have we got? Alright, so we got what we wanted there with the 2 zeros. 1, 1, 2, 2, 3, 3, yada, 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 up to 9. And yep, we got rid of that last 9 successfully. And the output is a single 0, multiples of 256, up to the last one. What else was it? Oh yeah, play. We haven't got the right length there. We need to store in this internal animation the length, so the number of frames. I'm going to put frames, here's the number. So when we store that, we put in the number we calculated, it's the number of frames, and then when we call that play, we want to animate the time up to that value. So up to, steal that line there. Should really make that a bit shorter, but you got to have this dot state, so what are you going to do? chuck that there, done, frames. It's a very short time period, we'll make it 1 second. Save it. Still no cats. What has happened? I guess we could keep that callback and call play again just to make sure it's looping. This play. At the start we'll set time to 0 again. And set value to 0. What have I done? I didn't 0 index it, did I? Ha! Ha! There we go. Alright. Cat. 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 There's no cat. Okay, it's got the 0 in the translation. Why not? Oh, wait, there is a cat. There is a flashing cat. Fascinating. Am I moving it in the wrong direction? I'm probably sending it to the right when it needs to go to the left. Put a negative sign on it. Hey, there we go, look at that. That is a cat doing things. Is that really a period of 1 second? 1. Yeah, that's fair. It's actually only a 4-frame animation. I just kind of extended some of the, so like the high point stays up longer and the low point stays longer. So I'll make it a bit shorter. A bit less. Ooh, that is too fast. You're a booty boy. Okay. There we go. Bouncing cat. That is very cool. Now that we've got that working, I think I want to make it so that I can dynamically change the sizing of it. So I want to be able to put in to the sprite sheet itself, into the props. I want to give it something in this style and be able to say, hey, I want the width to be like 50% of the container it's in or 20% of the container, and just have like relative styling and be able to have it dynamically match to that rather than sort of hard coding frame sizes and stuff in. So let's have a go at that. So we're going to try and get rid of this frame size part. So we want to, when the view, the outer view does its layout, we want to do a callback and store the measured width and height of it. That means when we put this thing in, we're going to have to make sure that we pass in a style object that does have a width and a height defined. So let's put that in now. So style equal aspect ratio 1. I'm going to make sure that this sprite is a square. And let's go height. And let's make it 50% height. Set the width to undefined. That means it'll just remain a square with height 50%. So let's see what happens when we do that. It's probably going to be a little bonkers. Save it. Alright, so we can see the sprite is being cut off at the right and at the bottom because we still have that hard-coded 256 for the size, but we've set it to be 50%. So that'll be even more evident if I make it like 30% of the height. So you can see it's really cropping it there. So I want the sizing of that outer container of our sprite to be defined by the user from the outside. Alright, so we're going to abolish this frame size by doing some calculations when the outer container does its layout. So I'm going to go on layout. I'm going to make a function called this.onLayout, which is going to take in the actual layout event, which is a layout change event. What have I done? Equals. You can see from hovering over it that onLayout does take in a layout change event. That's a good way to just see what that type's going to be. And then what we're going to want to do is recalculate our, or maybe for the first time, calculate our interpolation ranges for what the translation value should be for those X cat values. So let us take out this calculation we did in the constructor, because when we first run this, we're not actually going to have the sizing measured yet, so there's no point in calculating it there. What we'll do is we'll add a size value into the state. Again, for this, we're just going to assume that all of them are going to be squares, so I won't worry about having like a separate width and height measurement, so we'll just make this a number. Change this to a default frame size, which we will use when we first set the state. So size equals default frame size. That won't really be used, it's just something to be there to start with. Then generate gen interp ranges. So we're going to generate the interpolation ranges, taking in the size that we measure from the layout event. And we'll bung that in there. And in here. Actually, you know what? I'll just make this the on layout. Gen interpolation ranges, and I'll just put that straight in there, just so it's a little clearer. So const size equals event.native event.layout.height. Because we're assuming it's a square, we just need one of those lengths, so we got the size. And instead of frame size, which we hard-coded previously, we're going to put in this size we've just measured. Actually do the calculation of it. Need that initial definition of the internal animations, and then after that, we are going to redefine the state. So we're going to change only two of those things, this state. So we're going to spread those previous state values in there and just change the ones we calculated there. What am I missing? La 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 la. There's the cat animates. I chucked a white border around it just so you can see that's the outer div there, or view. React Native. See, I've just chucked a white border on it so you can see a bit more clearly what it's doing. And now I'm going to try out some different heights and see if it scales okay. It does not. Or at least it doesn't update when because I'm just doing a fast refresh on here, which means it's not actually calling that on layout again. So let's see what happens. Yeah, so that's scaled nicely. Try like 80% and I'll refresh it. There we go. That is some nice sizing. Okay. I'm going to squish it back down again, because it looks like something's going on that's, at least at the very start of the animation, it's getting a bit stuck. It's probably to do with that delay for the on layout. So when it's first waiting for that on layout to call and to get those sizes, it's kind of like, it just kind of stays still. So I'd rather it not actually be visible during that period. So I might make the opacity low and then either fade it in, or I'll just make it appear as soon as the animation actually starts. So let's try that. Let's go over to the Spritesheet, add into the style. I chucked these in before when I was debugging. I also added the measured size to the height and the width. The width takes the number of columns we specified earlier and multiplies it by that size to get the right width. So without those, the cat wouldn't actually change from the original image size, and you get all these weird effects with it just going out of sync. So it's important to set those sizes there as well. But for the opacity, let's go this.state.loaded. If it's loaded, make it 1, otherwise 0. Let's try refreshing it and see what happens there. So you can see to start with, nothing happened, and then it kind of floated for a sec. It's still doing a little bit of a delay at the start. Why is it doing that? I will do a plain in the state. So let's go plain, start off with false, add it to the state interface, so plain. Spreading the previous state when we set it in this on layout section, so we don't need to change it there, but when we play it, we need to set, what do we do? This dot set state. Let's go this dot state. Alright, so I worked out what was going on. When I was calling this set state to set plain to true, I was using this dot state in here, which was stale, so it still had the old values of like the size and whatnot in it. So what I did was I changed this set state callback to use the previous state and then included that. So the previous state here is the updated state, which has all the new stuff in it that I've stored, like the size and the loaded state and all that. So it's spreading all that, and then setting plain to true. So that's working. So if you see, if I do a proper refresh here, you can see that we don't get that little pause of it flying in the air beforehand. It only appears when it's actually loaded. So I could change that to a fade or whatever suits. But yeah, that is pretty good, and it's doing the dynamic sizing as well. I'm probably going to call it there. I think that's a decent idea of how that works. Just to summarize, so we created this Spritesheet component, made it a class with the parameters of the source image, number of rows and columns. Oh, we didn't get up to the frame rate. Ah, that's okay. I'm sure you can work out how to do that. It's just a bit of simple division. Animations, which we can define in here with a name, the row that sprites in, and then the number of frames for that row, the default animation that we wanted to start with. Again, we could put a parameter in here easily to just say autoplay, which would just like run this or not run this when you first measure that. Yeah, so those are the inputs. We store this internal representation of the animations in our state, along with a few other parameters. Calculate the interpolation values there. When we do our layout for the component, so we do that nice bunch of pairs of numbers to get that discrete shuffling as the time moves along in the image. Yeah. I think that turned out alright. I'm really happy that I can do some dynamic sizing now. I can just switch this up by percentage height or width or whatever, and it'll reallocate everything. So that's going to be super good. Looking forward to doing more convenient components like these for the rest of the game. It's going to make it much easier to put shit together. So that's probably it for this one. I hope you learned something from my rambling and debugging and whatnot. I mean, there's some stuff in there. If you have any questions about anything, let me know. I can post the code if anyone's interested. I'm probably going to do like a final version of this with a lot more features, and it's just going to be neater and everything. So yeah, let me know what you thought. But yeah, that's all for now. Catch you later.